Hey, what's up, guys? This is Chung again. So, this time 1591, string printer number 2. Mm, so this time the string printer will print following the below the two special rules here. On each turn, right, the printer will print a solid rectangle, and this will cover the existing colors in the rectangle. And second, once the printer has used a color, then the same color cannot be used again. So which means that one color can only be printed once. Okay, and then you're given like a matrix, and the value on the matrix are the targeted values. And your task is to check if it's possible to print a such matrix by using this string printer, otherwise false. So for example, this one, right? So the target matrix is like this. So obviously, the first time we need to print 1, and then second time we'll print 2. Okay, and the example 2 is a like more complicated one. So for this one, again, right, the first time we'll print once on all the cells, and then then we print 3, and then we print either 5 or 4. It doesn't really matter. So that's that. And there are like a few examples that cannot print to the final result. And there's some constraints here, right? So I'm to like within 60. Mm, so so how do we approach this problem, right? The I think one thing we need to observe is that, for each of the colors, and in order to be able to print this color, since it has to be a rectangle, it means that we need, at least for each of the colors, we have to print within a range, right? Because the printer can only print a rectangle. So which means that for each color, the first thing we need to do is that we need to get the border for this color, basically the left, the right, the top, and the bottom. So which means that we can pre-process this matrix, and we can use a dictionary or hash map to store the 4 borders for each color. And once we have that, I think next thing we have some options, but the way I use to solve this problem is that by using a DFS search. And to be able to write the DFS logic, so we also need to explore some of the examples that will return false. So for example, this one, right? So for this one, we have 1, 2, 1, 2, 1, 2, and 1, 2, 1. So why this one is false, right? This is because, let's say we try to print from top left corners, and then we try to print everything. So here, if you want to print 1, since the border for 1 is what is from left to right, basically it's everything. It means that we have to print ones all together, and then while we're printing ones, since we have a 2 here, and if we want to print 2, right, then we also need to print the entire like the array here, the entire board here. But while we're printing 2 here, we see, okay, so there's already a 1 that we have been previously printed, and then that's why the answer is false, right? So another example is like this one. So we have a 1, 1, 1, and then 3, 1, 3. Again, right? So first we print 1, and once we print 1 there, the next one we want to print is 3. But while we're printing 3 here, we see that, okay, so while printing 3, we need to print this one. We also need to print this one to 3. But we see, okay, so but this number here is 1, which are the colors we have been printed previously. That's why we need to return false. So then we have this conclusion, right? So the conclusion is like this. So every time when we do a DFS print, every time, let's say we start from 1 here, and we start from 1, and then we try to print out everything based on the borders of the current colors. And once we have seen a different colors, then we'll start print that one. We'll start print that color. Basically, that's a DFS recursive call. And every time when we try to print the colors, if we have seen a cell that equals to the previously seen uh, cell, the colors are previously printed colors, then it means that there's a conflict. Then we need to return false, because for example, if this one, since it's returned true, let's say we are printing 1 here, and then we have a 3. Now the DFS will go inside to print 3, right? So we print this one, this one, this one, and this one, because uh, but there's no ones on the range of 3, right? Because while we're printing 3 there, all we can see is 3 or 4, right? So because the last one is 4, but it doesn't really matter because 4 has not been seen or has been printed yet. Only 1 has been printed yet. As long as there's no ones while traversing, while trying to print 3, then we're okay, right? And then so while we're at here, that and then 3 has been printed with no issues, right? And then the last one is 4 actually. So while we're seeing 4 there, we'll start printing 4. So the 4 is also okay because there's no 1 or 3 while printing 4, and then 5, so on and so forth. So which means that we're gonna maintain, while we're doing the DFS, we're gonna maintain the like a previously printed colors. Basically, it's gonna be a set, and then we just try all the colors. If all the colors have passed the DFS check, then we're gonna return true. Otherwise, as long as there's no one color that failed, then we know, okay, there's gonna be it's gonna be a false. Cool. So then let's try to do the coding here. So like I said, I'm going to create like a border like as a dictionary to store the border for each of the colors, right? And then we have an m equals to the length of the target grid. And I'm gonna do this. And then n equals the length of the target 0, right? So for I in range of m and for j in range of n. So the current color, right? The color is the T, I, and J, right? So if the C is not in the border dictionary, right? So we simply do a border colors equals to what? Basically I'm having 4 elements, which is the top, down, left, and the right. Else we just update, right? We update the border of C equals to the what? So first one is the left, right? We could do a minimum of I dot border dot color dot 0, right? That's the left, and for the right is max, right? I dot border C dot. Now this one is 1, right? Then similar for the top one, minimum of J dot border C dot 2. Then I have the bottom one, it's maximum j dot bother c dot 3. Yep. So that's how we did I think I have a yeah. So now I can just simply loop through the colors, right? So the colors is actually it's the set in the border, the key of the borders, right? So I can just do this one colors, right? And then um, we're gonna have like two things. So we have, the first one is the scene one, right? The scene, the set, and then we have a in progress. It's also a set. So basically we're maintaining two sets here. So for color in the colors, and if not DFS, right? If not DFS colors, then we simply return false because it means that this color has a conflict, which means we need to return the false. Otherwise, in the end, we return true here. So now the DFS, right? So for the DFS, like I said, so if each color, if basically, so that one of the exit point, exit entry point is if the current one in progress, right? Then we just return false, like I said, right? Because if the current one has been uh, printed previously, and then we just return false. And then otherwise, we just try to print, right? For this color, basically we have the border of the so it's going to be a color dot 0, right? That's going to be the row, and the border dot color dot 1 plus 1. Right? Similar for the for columns, we have J here. It's going to be a 2 and a 3. Okay, and then basically if the target dot I and J is not equal to the current colors, then we need to do another DFS, right? But first, since we are but first we need to update the process actually. Yeah, we need to add the process, right? In process one is the current one. Yeah, and then we do and then later on we'll remove it. Okay, so that's because whenever we need to do a recursive DFS call here, we need to add the current one to this in progress, so that later on, we can use this one to return false here. And then basically, if not DFS, right? So if the DFS return false here, we need to return gonna be a target I and J, right? If this one is false, we also return false here. And in the end, we return true. So yeah, so basically here I'm doing the every time when I see a different colors while printing the current colors, I'll go like to try to print that color. Okay. And while printing that colors, right? If the color has has a conflict with the previously printed colors, then I simply return false. And as long as there's one element that can return false, then the whole thing will need to return false. Otherwise, if everything works fine, then I will return true. And that's how how I check the colors. Okay, so that's the basic logic. But if you just leave the code as it is right now, it will TLE. So the reason being is that let's say since we're doing like a for loop check here, right? And for each of the for loop here, we do another like another DFS, which means that if we have like many ones here, right? For example, for the first one, you know, we while processing the current colors, we might also like what we we will also we'll also print, basically process the nested colors. And since we're looping through all the colors, because one, let's say if there's like one here, right? So if there are like 10 colors, if well, and the first one is the colors that we process first, right? And then we'll basically while processing the first colors, since we have DFS here, we will also process all the nested colors inside. So that's why we need to introduce a second set here to help us to not reprocess the same colors. That's why the every time, right, once a color has been printed successfully, which means that the for loop is finished, which means that we have print all the cells for these colors. We're going to add this color to the scene set. And then on the top, right, we can just do this. If this color has been processed, or I think we can call it this one, processed. Or let's do this, printed, and this one is printing one, then printed. So here, if the color has been printed before, then we simply return true, right? Because it means that, you know, it has been processed, so we don't need to check that. Otherwise, you know, so this one is printing, right? And this one, and same thing for this printing, and this printed. Okay. Yep, I think that's pretty much it is. So run the code. Current. Oh, C. Yeah. Okay. So it's accepted. Mm, right. So how about the time and space complexity? So for the time complexity, so here we have m times n, right? So here's at m times n, but that's not the the dominating time complexity. It's actually this part. So here we have the first one is a color. Let's say the first we have a C means the total number of colors, and then inside here we have what? We have in each of the DFS we have a for loop. Okay, so the for loop is going to be a C times M times N, and inside the for loop here we'll also do another DFS call, which means that, you know, we're gonna have like another times C here. So this is because we only do the DFS when the color is different than the current one. That's why at most we will do the DFS C times DFS call within one loop, right? That's why the total should be, I think, C times M times N times C. Yeah, and so that's the time complexity. So for the space complexity, it's just the border and the printed and the printing colors. Yeah, I believe the border will be the dominating space complexity because this one has a has a space. So the colors it's going to be uh, 4 times C, right? Because for each of the colors we have 4 element, but for the printed and printing here, right? It's all basically it's all of C, right? But now this is a 4 times C, so that's gonna be the complexity analysis here. Mm, cool. Yeah, I think that's it. So for this problem, you know, two things, right? So first you have to uh, you need to pre-process the border for each colors so that you can use them, try to print them out later on. And second one is that you have to be able to find the what's going to be the condition for returning false. And the condition is the while printing the current color, right? And then uh, if we see a different colors, I will try to print that color instead. And while printing that colors, if if any uh, if any cell, right, that on the current path while printing the current colors is the colors we have been printed before, then it's gonna be a false. Otherwise, it's gonna be true. So that's why we basically we're introducing two set here. So the first one is the printed, which help us to record what are the colors we have been printed successfully, right? And to avoid some duplicated calculation. Second one is the printing for the current colors, right? So if there's a how many colors we have been printed before, which is our printing, and here's like backtracking, okay? Because the I think this part is also kind of obvious because after printing the current colors, right, we're not printing that colors, right? For example, the 3 and 4. And so once the color has been printed successfully, and then we need to remove it from the current printing set. Mm, yep, I think that will be everything I want to talk about for this problem. Okay, thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.